packet you got before break had the calendar on it. This is just like the extra stuff in this unit. So today we are doing limacons.
It's like cardioid.
They are not limacons. Nope.
It's a cardioid, like there's a thing inside of it.
There's cardioids, there's inner loops, there's convex, there's the whole, yeah. We're going to go through how you know what they all are. Okay? Guys, we are going to start just by plotting points so that you can see what the general graph looks like. We're going to plot them in order because when you graph these over a specific interval, you're only going to graph a little section of the picture, and you need to understand which piece of the graph you're actually looking at. So we're not just going to plot random points and connect them. We are going to plot them and connect them in order, just so you can see. Okay? So the first one here, we've got r equals 1 plus 3 sine of theta. So I would start with a theta of 0. So if I plug in 0, what is the sine of 0? 0. Okay. 0. Plus 1. Ooh, yeah, that's a good start. How many of you are really glad that I didn't give you a time tree quiz today? Oh, yeah, I thought that would just be way too mean.
I would probably walk right back out.
All right, so let's do pi over 6 next, because that's not too bad for sine. What is the sine of pi over 6? Half.
I got like 1 over 2. I said 1 over 2 instead.
So you only put the 2 out loud. All right. 3 times 1 half is 3 halves. Plus 1, what do we get? 5 halves. Okay. All right. Plugging in pi over 4 and pi over 3, those are both going to be pretty ugly for sine, right? You have radicals in both of those. So let's go all the way to pi over 2 next. So what do I get when I plug in pi over 2? Okay, sine of pi over 2 is 1 times 3 plus 1. 4. Okay, good job. All right, what do you think I want to plug in next? 5 pi over 6. Yeah. What am I going to get for 5 pi over 6? 5 over 2 again. Good. Let's plug in 5. What do I get there? Let's go ahead and do 7 pi over 6. So what's the sine of 7 pi over 6? Negative 1 half times 3 is going to be negative 3 halves plus 1. What do I get? Negative 1 half. Let's do 3 pi over 2. So what's the sine of 3 pi over 2? Negative 1, right? Times 3 is negative 3 plus 1. Okay. I know there's not a spot for it, but what do you think the last one we should plug in is? So yeah, let's do 11 pi over 6. What do you think you're going to get for 11 pi over 6? Negative 1 half. Okay. All right. Are we okay with the chart? Like you can make that table, right?
Yeah.
You guys didn't forget all of your trig values over break. Not all of them? Only a few. Okay. That's good. All right, so let's start plotting them. Remember, what you do is you go out the distance of the radius. Positive is to the right, negative is to the left. And then you travel around the angle. All of our angles are positive, so they're all going to be going counterclockwise. So I'm going to travel out 1 and then go nowhere. So there's my first one. All right, then I'm going out 5 halves. That's like 2.5. And I go up to pi over 6, which is 30 degrees. Then I go 4 to pi over 2. Then I go 2.5 again, all the way to 5 pi over 6. which that's 150 degrees. All right. I'm going to go 1 and then travel around pi. Okay. After that's where it gets a little trickier because I'm going to go negative a half. So that means I go left a half and then travel around 7 pi over 6. Okay. So left a half takes me over here, then pi over 6, 5 pi over 6. You guys see how 7 pi over 6 is actually where 30 degrees is? Okay. So that's kind of a weird one. So it's like a little dot in there. Then same idea with negative 2. So I would go left 2, so over here 2, and then I have to travel 3 pi over 2. So starting here, this becomes pi over 2, pi, 3 pi over 2 is up there. All right, then negative a half, 11 pi over 6. That's going to be right in there. Okay, so if you just look at those dots, those are some odd looking dots, aren't they? Okay, so we are going to connect them in order. So I start with a 0, come around 1 and 30 degrees there. Hopefully you draw better than I do on this thing. Okay, it goes through the pole. This is what's called an inner loop, which you guys see the loop on the inside. Okay, does that make sense? That always crosses at the pole. But you started here, you went all the way around, and then through the center and up to that, and then you connect. Okay. So your type, that is an inner loop. And guys, when we get done with all of the types of lumisons, then I'll show you the rules. It's very simple to tell if it's an inner loop, a cardioid, a convex, or a different. Okay. All right. Questions on the first one? All right, this one was sine. Do you see how the graph is sort of symmetric to the what would be the y-axis? Okay. This one has a cosine in it. What do you think it's going to be symmetric? Okay. Good. My numbers are different though, so let's look and see if this is an inner loop or if this is something else. I want to give you a few minutes to fill out the table. Again, I'd go in order. I'd start with 0. Do you think we want to use pi over 6 with cosine though? No, probably pi over 3. Yeah. Because these are the values I'd plug in. Yep. And again, there's not really room for that 5 pi over 3, but I'd squeeze it in there.
Let's see, 4 pi over 3 at 2 times.
Yes, just think you're working your way around the circle. Yeah. How you doing, guys? Are you plotting your points? Okay. I'll plot them too. Are those what your drafts look like, guys? Or do we need another minute? And then we'll connect them in order. This one's not as confusing to connect in order. Is there a loop on this one? Alright, so starting at that first one. You guys see how these are all pretty circular looking, just with some oddities to our circle? Okay, they should all stay very round like that.
The whole, that's the angle. I mean, sorry, not the rounded. At zero.
It's a little bit roundy.
A little.
Yeah. I'm not gonna be super picky on how, don't draw it like, don't draw a cardioid like that, okay? This is called a cardioid. Yeah, it kind of looks like a heart. So far, inner loop and cardioid, those names kind of make sense, right? All right, guys, questions so far?
Google.
I could be adding an I just for. I could be just sounding it out at night.
Is that how you pronounce it? Cardioid? Cardioid. Cardioid.
Yeah, it should have the I. So add the I on the next page. Okay, good. All right, questions on the cardioid. So what do you think if it had been a sign in here? What would be different about this graph? Yeah, it'd be like on the Y, essentially the Y-axis part. Okay. All right, so number 3, again, we're dealing with cosine. Again, our numbers are a little different. So for your thetas, I would use the 0 and then the over 3s, because again, it's cosine. Pi over 2, 2 pi over 3, pi, 4 pi over 3, 3 pi over 2, and then again, no room for it, but squeeze in that 5 pi over 3. chart. Plot your points. So once you have your dots plotted, again, connect them in order. Start with the 5, 0 over there. Again, I hope yours is prettier than mine. That's gonna look like a one. So guys, if you notice the cardioid, do you see how it went all the way to the pole at that middle point? Does this one? No, okay. So it's not a cardioid. This is called a dimple because it's a little dimple. That is a dimpled limacon. Limacon. You're in French, right? It probably is. It is not not lima bean. Not lima bean. It still has lemon biscuits. It's like a lemon biscuit. Oh, lemon biscuit. Okay, here's just making up the word. Dimpled, D-I-M-P-L-E-D. Yeah, I know, it's just a normal word. Do you guys see the difference in the graph between that and the cardioid? Okay. We have one more type. Anybody need more time on this? When you're ready, go ahead and turn the thing. Okay, we're doing another cosine. I don't know why, we just like cosines today. So, same idea, let's plot your points. 0, pi over 3, pi over 2, 2 pi over 3, pi, 4 pi over 3, 3 pi over 2, and then pi. So your first one is 6, which is a little bigger than your graph. So just put it out there. It's almost like a circle, but it's pretty flat over here, guys. I don't know if you can see. I'm not graphing it in order just because I was struggling to draw my picture. You guys see on the side how it's fairly flat? Okay. That is called convex. It is almost a circle. It's easy to get like off a line on your graph when you're counting the points too, so. Yeah, I think it's just projection. Yep. You're good. Questions on this one, guys?
Yeah.
You can tell it's by my drawing, but I think the bigger they get, the harder it is to make them look.
Why do you put it there?
I don't. All right, guys. So those are the 4 types of lemmason. The way you can tell quickly what the shape should be is all related to these numbers here, like this 4 and this 2. It's hard to see on my screen, but do you see down here these 2 little equations? R equals A plus or minus B sine of theta, and R equals A plus or minus B cosine theta. The A and the B are what you always look at to determine whether or not it's an inner loop, cardioid, whatever it is. So if you look at the formula here, if the absolute value of your A and B, like we don't care if it's a plus or if it's a minus, it doesn't matter. That's just telling you is it going to the right, to the left, up, or down. That's what the plus and minus do. We're looking at just the ratio of A to B. So when you put A over B, if it's less than 1, we know we have an inner loop. So if you look back at that first one, think about it. Our A over B here was 1 over 3. Okay, definitely less than 1, right? And so that was equal to a lemmason with an inner loop. Okay? If your A over B is equal to 1, it's a cardioid. So look back at the second one we did. 2 over 2. That was equal to 1, and we had a cardioid. Okay? The next one was dimple. And this is the only one that's a little weird. Your A over B is somewhere between 1 and 2. Okay? So if you look back at our third one, your A over B was 3 over 2. Would you agree that's bigger than 1, but smaller than 2? Okay, and that's why we had dimpled. And then the last one, 4 over 2, that equals 2, right? So if it is greater than or equal to 2, that's when you get a convex. Okay? And if you think of them in this order, it's easier to remember. You're going from the smallest thing, so less than 1, equal to 1, between 1 and 2, and greater than or equal to 2. Think about it being like a balloon that's being inflated. The inner loop is when it's kind of all folded in on itself. You put a little bit of air into it, and it turns into a cardigan. A little more air, it's dimpled, and you've like filled up your balloon at this point. Yes. Your A over B equals 0, that's a circle. That's because A doesn't exist. What does
Wait, A doesn't equal. Wait, what do you mean A doesn't equal?
like it's 0. Because 0 divided by 8, I think.
The radius equals close.
Depends on how it's written.
So what if B be 0?
You can't divide by 0.
Yeah, I know, but like B is the coefficient of the cosine.
Yes.
But with a circle, there is no cosine, so B will be 0.
We'll look at circles again. Okay, but you can't divide by the circle,
Yeah, I
so
know.
that's okay.
But the way it's written
It's not, I agree. So guys, the 4 you're focusing on today are the limitons. Okay? If you have questions on any of those or how to tell those 4 apart. Okay. So let's practice some of these.
Do we have to graph
What do people just call them limitons?
I don't know.
No.